Next point is here about solutions of trigonometric equations. So we solve the trigonometric equations. Earlier you have solved quadratic and linear equations like this. If you are given this equation 2x plus 1 equals to 0, then what is its solution? X equals to minus 1 by 2. This is called solution, That is the values of x that satisfy this equation. If you are given this quadratic equation, you know what are the possible solutions. X equals to plus or minus 1, which you did even in 10th standard. If I put 1 here, this becomes 0. If I put minus 1 here, this becomes 0. So this is for such linear or quadratic equations you have studied with solution. Now we'll go for trigonometric equations. For example, I have taken, let's take x equals to, not x, trigonometric equation. Suppose I have sine x equals to 1 by 2. The question is here, find x, in fact all possible x for which sine x become 1 by 2. Then the obvious answer, it is pi by 6, 30 degree, right? This is one value. The question is, do we have any other value for which it becomes 1 by 2? So answer is yes. You can try, even if you take pi minus pi by 6, which is 5 pi by 6. This is also solution of this, you can verify. Find sine 5 pi by 6. You will realize you will get exactly 1 by 2. That means this is also solution, x. So now question is, how do we keep on trying this way? That's a question. So we have here now 3 standard solutions. This is what we want to discuss here. That's the main part. Suppose I'll take one more here. This is one simple example. Let's take I have cos x equals to 1. Solution of this equation, right? Solution of this equation. Solution means what? Get all possible x for which cos x become 1. That's what you did here. Get all x for which x square minus 1 becomes 0. That is plus or minus 1. And these are called solutions. So here we find all x for which cos x become 1. So 1, obviously you can recall x equals to 0. You know cos 0 is 1. Are there any other value? Answer is yes. You can try 2 pi. You know cos 2 pi is 1. You can try 4 pi. Cos 4 pi is also 1. So these are all solutions. So normally you have infinitely many solutions. 6 pi, then 8 pi and so on. So now in general it's very difficult to keep on trying on this. So we have 3 standard formulas here, solution sets. So solution sets here, solution sets. First we go for, suppose we have cos x equals to, let's write here a, small a. Here a is 1. Here a is 1 by 2, that way. So cos x equals to, in short, constant. So what's the solution set for this? I repeat again, solution set means values of x. So x equals to, without proof we are writing 2n pi plus or minus here y. What is y there? Where y is nothing but the cos y equals to a. That way it is obtained. What is y? That is, you find angle for which cos becomes a. That's the formula. And of course n belongs to z. So these are infinitely many solutions, remember, because if you take different values of n from z, you will get the different solutions. It has proof. You can refer to the textbook, but you need to remember what's the solution set for cos x equals to a. That is x equals to, again I repeat, solution means x for which if I put this value here, you will get this. That's what I've tried here. And for cos function it is 2n pi plus or minus one angle. How do we get that angle? That angle is nothing but the angle for which cos become this number. See here that pi by 6 comes from these only. What is sine pi by 6? It is 1 by 2. That's why you have placed your pi by 6. What is sine 5 pi by 6, which is 1 by 2? That's why you have chosen this, so that way. So solution set for cos function, it is 2n pi plus or minus y. That's one thing. Now we write the solution set for sine function. Solution set for cosine, again I repeat, 2n pi plus or minus y, where n belongs to z. Next, sine function, sine x equals to a. Solution set for sine. What's the meaning of this? We find all x which I put here, I'll get the answer equals to a. So here it is given by x equals to n pi plus minus 1 raised to n into that angle for which sine becomes a, where sine y equals to a and n belongs to z. Find x for which sine x become a. So this is called solution set here for sine function. N pi plus minus 1 raised to n into y. Why we have this n here? Because you have rotations around unit circle, you know. So there are infinitely many values. This is not just one. You know, here you had just one solution. These are the two solutions. But in trigonometric functions, you know, here 0, 2 pi, 4 pi, 6 pi, 8 pi, because of the rotation around the unit circle, you have infinitely many solutions, remember. For cosine, 2n pi plus or minus y. For sine, n pi plus minus 1 raised to n. What is this minus 1 raised to n? If this number is even, then you will get the plus sign, like minus 1 raised to 2. If this number is odd, suppose if I put 3 here, then you will get the minus sign. So minus 1 raised to n just indicate the plus or minus. So this is a solution set for sine function. And one more, that is for tan x. Third one, that is solution set for tan x equals to a. So which is given by here x equals to n pi plus y. What is this y here? Where find y for which tan y becomes this a. And you know here n belongs to z. I repeat, solution set for tan x equals to n pi here, n pi plus y. What is this y? Find y for which tan y becomes this number. Fine. So these are the three solution sets. I repeat this. Recall, for sine function, here x equals to n pi plus minus 1 raised to n into y. For cosine function, x equals to 2n pi plus or minus y. For tan function, as I wrote, x equals to n pi plus y. How do we find y? Find y for which tan y becomes that number on RHS. Find y for which cos y becomes that number on RHS. Find y for which sin y become that number on RHS. So these three solution sets, everywhere of course n belongs to z. You need to remember. Okay, these are called general solutions sometimes. These are called general solutions. General solution sets, yeah, general solutions. So general solution set would be this in form of n here. But sometimes here we have solutions from 0 to pi. Solutions of trigonometric functions from 0 to 2 pi open. That is first rotation. Start from here and complete one rotation. This is solutions from 0 to 2 pi. That's called sometimes principal solutions, mean solutions. The other solutions comes by repeating things that principal solutions means what? Solutions from 0 to 2 pi. Like for example here question is find, this is a question, find the principal means mean, principal solutions of the equation, trigonometric equations, sine x equals to root 3 by 2. So what you will do? You find the value of x for which sine x becomes root 3 by 2. So obviously x equals to pi by 3. Sine pi by 3 is this. And this is positive. So pi minus pi by 3 will also do 2 pi by 3. These are principal solutions. Right? These are the values of x which I put on the left hand side. In place of x, I'll get the RHS. That's the meaning of solutions, number 1. Number 2, why these are called principal solutions? Because pi by 3 and 2 pi by 3 are in the first round only. No other values can be obtained, remember. Right? These are the values from 0 to 2 pi for which sine x become root 3 by 2. So these are called principal solutions. Now what about the general solution? If you want to write general solutions set equals to, why we are writing set? Because there are infinitely many solutions. X equals to, I'm just using this formula for sine. This formula I'm using, n pi plus minus 1 raised to n into y. What is y? The first one, this value, because sine pi by 3 is root 3 by 2 into pi by 3, where n belongs to z. This is your answer, right? This is not just one value, remember. These are infinitely many values which I put in here in place of x. Every time I'll get root 3 by 2. You suppose I have taken n equals to 0. Put 0 here. Something raised to 0 is 1. So you'll get directly pi by 3 first. In general solutions, principal values are included, remember. So now we go to exercise 3.4. Find principal and general solutions of the equations given below. First equation is tan x equals to root 3. So you just recall the general solution, x equals to n pi plus y. What is this y? For which cos, here 10. So 10 y should be root 3. That's what you need to do. So therefore here x equals to n pi plus for first value, which is here pi by 3, where n belongs to z. This is a general solution. N pi plus pi by 3, where n belongs to z. How you got this pi by 3? Find y for which 10y becomes root 3. This is a general solution. These are the infinitely many values of x which I put here. I'll get the root 3. Now what about the principal solutions? Principal solutions here, which you can do by taking different values of n. Suppose I'll put n equals to 0, pi by 3, which is in 0 to 2 pi. Next, if I put 1 here, pi plus pi by 3, that will do. Pi plus pi by 3. So what is that? 2 pi by 3. One is pi by 3, the other one is 2 pi by 3. Next, if I put 2 here, then 2 pi plus pi by 3. So it exceeds this. It should be in one rotation. It should be from 0 to 2 pi. If I put 2 here, then 2 pi plus pi by 3, it is more than 2 pi. So that's not possible. So only two particular solutions, pi by 3 and 2 pi by 3. You can do directly also. These are the principal solutions and this is the general solution. Question number 2. I have here sec x equals to 2. Now we don't have formula for sec, remember. We have only this 3 formula. Cos x equals to a, sin x equals to a, and tan x equals to a. Every time your question should be either in this form or in this form or in this form, remember. So therefore immediately you can write cos x equals to how much? 1 by 2. So general solution here, general solution if I write, you just need to use the formula, that is x equals to, for cos, if you remember, 2n pi plus or minus, find the first angle for which cos x become how much? 1 by 2. Find first angle for which cos y becomes 1 by 2. So you know that this should be how much? Pi by 3. So plus or minus pi by 3, where n belongs to z. N belongs to z. This is the general solution. I repeat again. These are the values of x which I place here. I'll get every time 1 by 2. And these are infinitely many values, remember. Because n comes from z. See, if I put n equals to 0, you'll get the plus or minus pi by 3. Put here, you'll get exactly 1 by 2. And so on. Why this is happening? Because you are using unit circle. So by repeating this, you will be having infinitely many values. That I suppose you must have realized now. Okay. Now next is, what are the principal solutions? So principal solutions means what? Solutions from where to where? 0 to 2 pi. So first is obviously pi by 3. That's quite obvious. Can you take minus pi by 3? No, because it should be from 0 to 2 pi. Then what is the next value? Next, suppose here cos is positive 1 by 2. So it will be in which quadrant? You know, first and fourth. So the next value you can write, fourth means 2 pi minus pi by 3. So pi by 3, that is one value. And what about this? This is 5 pi by 3. So finally we are getting two values, 5 pi by 3 and pi by 3. Both if you put here, it becomes 1 by 2. These both are included in this list, remember. But this both comes from 0 to 2 pi. So these are called principal solutions. Next question is cot x equals to minus root 3. Now we don't have solution set for cot. We do have for tan. So we just take the reciprocal. So what is tan x? Minus 1 by root 3. Okay. Now general solution. Here first general solution. What's the general solution? That is x equals to, for tan you know, n pi plus y. Okay, what is y there? Find y for which tan y equals to minus 1 by root 3. So get the angle for which this become minus 1 by root 3. So that usually we take from 0 to 2 pi, remember. So you can have 5 pi by 6, I suppose. Just find this, tan 5 pi by 6. It is 10, pi minus pi by 6, which is which quadrant? Second quadrant. So tan pi minus pi by 6, it is in the second quadrant. So 10 is negative. So minus 10 pi by 6. So this is minus 1 by root 3. Right? So this is your answer. This is the principal solution. Remember, when n belongs to z. The selection of y should be from 0 to 2 pi, always remember. You can take these also. You can write this, but usually this is also correct. N pi. You can take y equals to minus pi by 6 also, remember. That will do sometimes. Nothing is wrong here. But here minus pi by 6 doesn't come from 0 to 2 pi. So if you write this, doesn't make any difference, but in MCQ may have such option, may not be this. Normally both are same, doesn't make much difference. 10 5 pi by 6 is minus 1 by root 3, but this comes from 0 to 2 pi. 10 minus pi by 6 is also minus 1 by root 3, but this doesn't come in 0 to 2 pi. So normally we use this. This is not wrong, remember. This is not wrong. A B say, but normally we prefer this. Okay. Now principal solutions. Principal solutions. So values from 0 to 2 pi. So one value is obviously 5 pi by 6. 5 pi by 6. Now how do we decide the other value? You see, 10 is, either you can put different values of n here and find x which is from 0 to 2 pi, or directly from these also you can do. 10 is negative, so this x must be in which two quadrants, that you should check. In which two quadrant 10 is positive? You know 10 is positive. 10 is positive in which two quadrant? First and third. In these two quadrant, you know all S, T, C. So 10 is negative in which two quadrant? Second and fourth. You see here 5 pi by 6 is already in second quadrant. This quadrant here. Sorry, this one, second, this one. Now I want this fourth quadrant. So here 2 pi is there. So I can write 2 pi minus pi by 6. So here 5 pi by 6 as it is, and this is 11 pi by 6. These are the two principal solutions. I repeat this, how I got this. What you can do is, first you look at the quadrant of 10. Now 10 is here negative. That means 10 should be in which two quadrants? Second and fourth. Fine. Because 10 is positive in which two quadrant? First and third. Now second quadrant means what? Pi minus something. Pi minus something you already written here, 5 pi by 6. And fourth quadrant means what? 2 pi minus something. 2 pi minus something, that's a fourth quadrant. So 11 pi by 6. These are the two principal solutions. Fifth question, there you want general solution only. Cos 4x equals to cos 2x. Now you cannot solve this. You know that in trigonometric equations you must have either cos x equals to a, or sin x equals to a, or tan x equals to a. You have solutions for this three equations only, remember. So we reduce this one into this three, one of these three, remember. So what we'll do first, we use here equals to 0. This is a very common method. You put in equals to 0 form. Now you use c minus c. Now this is known to you. What is c minus c? Minus 2ss. Minus 2 sine this plus this by 2, which is 3x. Into sine, what about this? This minus this, 4x minus 2x equals to 0. Right? What I did, I've used here c minus c. What is c minus c? Minus 2ss. Fine. So minus 2 never be 0, so I'll take on the other side. So either sine 3x must be 0 or sine x equals to 0. Now here you doesn't require even formula for this. This, if you remember, set of zeros of the sine function. Can you recall? zeros of sine function. Sine x equals to 0 if and only if x equals to n pi. Beginning of Trigo functions. So here instead of x you have 3x. So what I'll get here, this 3x equals to n pi, or this is just this one equals to 0. So what is the x here? N pi. If you remember beginning of Trigo functions, we had zeros of sine, cos, tan and so on. Zeros means x for which function becomes 0. So what is x from this here? N pi by 3. What is x? That is same, n pi. So these are the general solution set where of course n belongs to z. N pi by 3 or n pi. What is the meaning of this? Again I repeat, if I put this x equals to n pi by 3 here and here, I'll get equal to or equals to 0 if I take on the left hand side. These and this, these are the values of x which I put on the left hand side, I'll get RHS. So these are the general solutions. Now next question, question number 6. Let's do that, what it says. Question number 6 is about cos 3x plus cosine x minus cos 2x equals to 0. Now what you need to do? You need to reduce either cos x equals to some constant, sin x equals to constant, or tan x equals to constant. Okay? Otherwise you cannot solve because you have solutions for these 3 type of the equations only. So we need to simplify this. How do we simplify? The one way is you can use here c plus c. You know this. What is c plus c? You know 2cc, twice cosine this plus this, 4 by 2 which is 2x, into cosine this minus this, 3x minus x, 2x by 2 which is just x, minus cos 2x equals to 0. Okay. So now you can find cos 2x common, you can see. So what will get inside the bracket? Twice cos x minus 1 equals to 0. So either cos 2x equals to 0 or this is equals to 0. Twice cos x equals to 0. Factors. Either this must be 0 or this must be 0. You know, product of two numbers is 0 means either this should be 0 or this should be 0. So what is important one? This one. Factorization. Basically this is factorization. That's what you did. You got the factors. Okay. Now how do we answer this? Equals to zeros means set of zeros of the cos function. Do you remember? It is 2n plus 1 pi by 2. Beginning. Just see the earlier sessions. Equals to zeros means zeros of the cos function, 2n plus 1 pi by 2. What about this? Here cos x equals to 1 this side by 2. So by 2. For this you need to use this solution set. So what is x here? X equals to 2n plus 1 pi 2 will come down. So by 4. Solution set for x. Do you remember? 2n pi plus or minus, find y for which cos y becomes 1 by 2, which you know pi by 3. So finally x equals to 2n plus 1 pi by 4 or x equals to 2n pi plus or minus pi by 3 where n belongs to z. These are the solutions. Values of x which I put here on the left hand side in place of x, I must get 0. That's the precise meaning of the solutions. And these are infinitely many values, remember. I'll go for question number 8 here. Sec squared 2x equals to 1 minus tan 2x. Now this will not do. what you need to do, this is about 10, so you need to express in 10x equals to some constant form. In short, factorization. Sec squared should be expressed in form of 10. You know, very well-known expression, 1 plus 10 squared theta equals to sec square theta. So in place of sec square, I'll write this, right? What I did, in place of sec square, I wrote 1 plus 10 square. Okay, 1 will get cancelled. I'll take this one over here. So 10 2x, this will get cancelled here, plus 10 square 2x equals to 0. Factorization, you can see that 10 2x you can find common. So 1 plus 10 2x equals to 0. So you got two factors, either this should be 0 or this should be 0. So therefore either 10 2x should be 0 or 1 plus 10 2x must be 0. Now here you again recall earlier sessions, this means zeros of 10 function. What is that? If you remember, that is same as zeros of the sine function, which is n pi beginning. Here you will get the 10x equals to minus 1. So at this place you need to use the formula of that 10, if you remember. So 2x equals to, not x, 2x equals to n pi plus, you need to find the value of x, or you can call the y, such that tan y equals to minus 1. So I repeat here, what we'll do is we find the y here, plus y such that tan y becomes minus 1, right? That's what you want to do. So usually we select the y from 0 to 2 pi, remember, that's normal practice. You can take minus pi by 4 also, 10 minus pi by 4 is minus 1, but it should be from 0 to 2 pi. If you take minus pi by 4 here, it will not be in this square, 0 to 2 pi, it is negative. So we can write here, now negative means either it is, which two quadrants, 10 is positive in first and fourth. 10 is positive in first and fourth. In this two quadrant, 10 is positive. These and this. Here 10 is positive. Negative means either this quadrant or this quadrant. So you can write here pi minus pi by 4. That's the second quadrant I've used. This quadrant. This is 3 pi by 4. This is just 3 pi by 4. You can verify that 10 3 pi by 4 is minus 1. So I'll write here 3 pi by 4. This is important, remember. You must see that how I got this 3 pi by 4. What's the solution set? N pi plus y. You find the y, you find this y for which tan y becomes minus 1. Now here it is negative. Negative means either this quadrant or this quadrant. So I'm using this. Now here your pi's, and 10 pi by 4 is 1. So that's why I wrote pi minus pi by 4. And what is that? 3 pi by 4. That is your y, remember. We are interested, now come to this. We are interested for x. So n pi by 2, or here if you divide by 2, n pi by 2 plus 3 pi by 8. That's your solutions here, remember. Either this n pi by 2 or this, where of course n belongs to z. This n belongs to z. N pi by 2 or x is equal to n pi by 2 plus 3 pi by 8. That's your answer, where n belongs to z. These are the values of x which are put on the LHS and RHS, both will be equal. That's what we usually call the solutions. Ninth question, you have sine x plus sine 3x plus sine 5x equals to 0. So what we do, as we did in earlier questions, we need to express this one in which form? Either in sine x equals to constant or cos x equals to constant in this form, or tan x equals to a. So factorization, remember. So summation to product. So we use here which formula? S plus S. We use for this 2s plus s. Why for this 2? You must have realized 5 plus 1 6 by 2. So we'll get the middle term. So here s plus s for this 2. What is s plus s? 2sc. So let me write that. Twice sine this plus this by 2, which is 3x, into cosine this minus this by 2. So minus 4 by 2 minus 2x, plus middle term as it is here, remember. I repeat this. S plus s for this 2. 2sc x plus 5x, 6x by 2 3x, x minus 5x minus 4x by 2. Sine 3x you will find common. So twice cos 2x plus 1 equals to, you know that the cos is an even function. Cos of minus x equals to cos x. You know this. That inner minus has no effect for cos function. So this remains as it is. 2 as it is equals to 0. Now either this should be 0 or this should be 0. So either sine 3x equals to 0 or twice cos 2x plus 1 equals to 0. Now next step is here. So here, what about the first step? First step is zeros of sine functions here. Zeros of sine functions. Equals to zeros means zeros of the sine function. You know it is n pi. Now we already used number of times. Or here cos 2x equals to 1 on the other side minus 1 by 2. Right? I hope this is clear to you. So we have this. So what is x from this? N pi by 3. So this is done. I repeat this. From where I could write zeros of sine function, which is n pi. Obviously n belongs to z. That I'll write at the end. Now here you need to use the solution set for cos function. What's the solution set for cos function? That you know, if I write here, if you remember, it is 2n pi plus or minus y. Okay, so I'm writing this here, or here 2x, remember, 2x equals to 2n pi plus or minus, find y, for which cos y becomes minus 1 by 2. This constant, just refer the theory, you will realize. Now what's the value of y for which cos y becomes minus 1 by 2? You can use here, see, cos is negative. Negative means it should be either in which quadrant? Cos negative, that means either it should be in this quadrant or this quadrant. This quadrant means y equals to pi minus pi by 3, remember. So this is 2 pi by 3. So here you will get the 2 pi by 3. And therefore finally x equals to, dividing by 2, n pi plus or minus 2, 2 will get cancelled. You will get the pi by 3. This is the solution. Either this or this. This is the solutions, general solutions. I repeat how I got this 2 pi by 3. I'll repeat this, how I got this. I'll again explain. See, what the solution set? You know, 2n pi plus or minus y. That's the solution. Now, how do I find this y? We find the y for which cos y becomes this constant, minus 1 by 2. Okay? Now here cos is negative. In which two quadrant cos is positive? In first and fourth. Negative means either this quadrant or this quadrant. So we are using second quadrant here. Second quadrant means pi minus something. Pi minus, find the x for which it becomes 1 by 2, which is pi by 3. So you are getting 2 pi by 3. That value of y I have placed here. Right? So finally this or this are the Jundal solutions, where obviously n belongs to Z. Right.